In this video, we'll take a look at some more spectra of various compounds, this time including halogens, specifically bromine and chlorine. We can identify the presence of a bromine or a chlorine by looking at the m+2 peak. In this particular molecule, we have bromobenzene, although perhaps we don't know that yet. We have our base peak here at 77. We have our molecular ion peak at 156, and we also have a very close molecular ion peak at 158. So our parent ion, 156, and our m+2 peak, we have two more, right? We have an m+1 peak, of course, that will tell us the number of carbons. We have an m+2 peak, which is very similar to the molecular ion peak. And we'll also have an m+3 that should be similar to m+1. And we'll take a look at why that is in just a second. Because we have another one to look at. If we look at chlorobenzene, by contrast, here, let me move this up a little bit. Again, we have our, our base peak this time is our molecular ion at 112. And we have, again, a significant m+2 peak, but it's not the same as we saw for bromine. And let's take a look at why that is. Again, this all comes down to isotope effects. So, the m+2 peak. So, two elements, bromine and chlorine, come in two different isotopes. Bromine has bromine 79 and bromine 81. Chlorine has 35 and 37. So both of those are separated by 2. And we see that for bromine, it's about a 50-50 ratio of those two. And for chlorine, it's about a 3-to-1 ratio of the relative abundance of those isotopes in nature. So, a mass spectrum of a compound containing bromine should have an m+2 peak that is almost the same as your molecular ion, because you have an equal chance of getting either the heavier bromine atom or the lighter bromine atom. And so, for bromine, we're going to look for of equal intensity. So your m+2 peak should be about equal to your molecular ion peak. For chlorine, you're looking at one that is significantly smaller, but not, still there, definitely still there. So for chlorine, you're looking for an m+2 about 3 times as large. As your molecular ion peak. So let's take a look at those again. So let's take a look at bromine first. So again, we have that M to Z peak. The m+2 peak, 158, is about equal in intensity to the molecular ion peak. With the chlorine, we see that it's about 3 times as large for the M peak versus the m+2 peak. And again, for both of these, the ones that have the carbon 13 will still be present. That's why we get these 115s and 113s. Or for the bromine, again, we have those this is chlorine. For bromine, we have 157, 159 of relatively equal as well, because they have an equal chance to also have a carbon 13. So, lots of interesting stuff here. So, that's how you'll identify the presence of other common heteroatoms. So, by now, you can figure out the number of carbons by looking at the m+1 peak. You can figure out the presence of chlorines or bromines by looking at the presence of a significant m+2 peak. Nitrogens you can tell by looking at whether you have an odd or even molecular mass. And finally, oxygens can be determined just kind of by making sure that your number of hydrogens makes sense after you've subtracted your carbons and any other known elements. All right, in our next video, we'll take a look at common fragmentation patterns in how to identify these smaller pieces of our molecules.